vector function. Okay. First of all, why we need a convolution? To understand the convolution, we will take any system. Okay, just starting. Convolution. See, either continuous time system T or a discrete time system Hn. Okay, if input is given to this, then we'll get some output by T. How to calculate this output by T? That depends on the convolution. Okay, see, the expression for Yt is minus infinity to infinity x of tau h of t minus tau d tau, or in terms of discrete time functions I can write it as summation k tending to minus infinity to infinity x of k h of n minus k. Okay, so this tau and t minus tau, they both are interchangeable. Either we can place in h function, or I can place in input function. Okay, or in system function, or can be in input function. The result is going to be same. So this is a general expression for finding the convolution. But how actually the convolution works? Okay, we will see that. See, suppose Hn is something like this. Zero, 1 and 2. And in case if input comes, I'll take a very simple example. Input is starting at n equal to 1. Okay, input is 0 at n equal to 0, xn equal to 0 at other place is equal to 1. Okay, and only 1 and 2 points are there. At n equal to 1 it is 1, at n equal to 2 it is 2. Now if this input passes through Hn, so that I will get an output Yn, then how the things will be? See, input is coming, the first value will be x equal to 0. The second value will be the first value will be n equal to 0, second value will be n equal to 1, third value will be n equal to 2. So how to manipulate the input xn such that the first value will be n equal to 0? What we will do, we will shift it by when we time reverse it, it becomes -2, -1. This amplitude is 1 here, this will also be remain 1. Okay, now take this input, superimpose over here and shift it inside Hn. Okay, take this input here, shift it inside Hn. So once we shift it inside Hn, at n equal to 0 what will happen? At n equal to 0, Hn is equal to 1, but xn equal to 0. That means Yn is equal to 0. Okay, at n equal to 1, at n equal to 1 what will happen? Hn, h of 1 is equal to 1, x of 1 is equal to also 1, but y of n, y of 1, I should write here, y of 1 will be equal to 1. Similarly at n equal to 2, y of 2. This will equal to 1 plus 1 is equal to 2. Like this, the process will repeat, and once the full input crosses or it crosses full Hn, the output what we'll get, that is nothing but a convolution Yn. Okay, so it is just like a multiplication and accumulate. We are multiplying and then adding, multiplying and then adding, multiplying and then adding, and this process repeats, so we'll get the final result. Now we'll see, just note down different steps in finding convolution. Okay. The first one is write expression for ht and xt in continuous time domain or hn and xn in discrete time domain. Okay. Now we'll reverse any of the expression, either ht or x, either ht or xt. Okay, we can reverse any of the expression, result is going to come same. Okay, so if I shift, I can write time reverse expression and shift it by t. Okay, that means we have converted our ht and xt to some other variable in the form of some other variable like x tau or h tau. Okay, or hn or xn in terms of other variable hk or xk. After this operation, we get expression for h of t minus tau and x of tau. Or if we shifted x of t, if we reverse the x of t, then I will get x of t minus tau and h tau. Okay, this is in continuous time domain. In discrete time domain, I will get h of n minus k and xk, or x of n minus k and hk. Okay, third. Now whatever the function we have shifted, suppose if I shifted xt and time reverse and shifted, then I have to move that function only. Okay, so whatever function I am time reversing and shifting, I have to move that function only by shifting the shifted function. Once we have shifted once we are shifting the shifted function, in that process it may happen that some portion of xt and some portion of ht may overlap. Okay, once the amount of portion which is overlapping, we will integrate that region, or we will sum that region, multiply and sum. Apply the common area in each case such that limits of integration differ. So whatever the limits of integration has come in the first overlap region, they should not repeat in the second overlap region. After doing this, we have to take all the cases and summarize for all values of t. So in that process, what will be the range of t? If if we want to know the range of t, we just have to sum the lower limit and upper limit. The range of t will lie between the sum of lower limit or to sum of upper limit. Like for example, xt lying between minus t, ht lying between this region, then yt will lie between minus 1 plus 2, 5 plus 7. So this is 1. Okay. So in this region, yt will lie. Now we will take up two problems, one in continuous time domain and the other problem in discrete time domain to understand the convolution. ht is given by 0.5 to 2.5. Amplitude is 2. xt is given by 2 to minus 1. Amplitude of this portion is 3. Okay. Find yt, which is xt convolve with ht. Okay. Solution. First of all, the range of t. Limits of t. The t will lie between 0.5 plus minus 1 2 plus 2.5. This becomes minus 0.5 less than t less than equal to 4.5. Okay. I'll write the expression of ht and xt in terms of h tau and x tau. So h tau is equal to 2 for 0.5 less than equal to tau less than equal to 2.5. Expression for xt can be found by using the equation of line. Okay, so I can write xt minus 0 is equal to 3 minus 0 upon 2 minus minus 1 t minus minus 1. So this will give me xt is equal to t plus 1. Now x tau can be written as tau plus 1. X of t minus tau will give me t minus tau plus 1. So this x tau is lying between minus 1 t tau. So this will lie between t minus tau. Okay. So tau is lying between t minus 2 t plus 1. Okay. So this first thing is finding the limits of t. After finding the limit of t, finding the expression for x tau, h tau x tau and x of t minus tau. Okay. Now just see the plot of x of t minus tau. See, xt is this. Okay. That means I can write x tau as equivalent to xt equivalent to x tau. Now x of minus tau will be what? Okay. X of t minus tau will be what? That plot will be something like this. T minus 2, t plus 1. This is tau. Okay. So you got the plot for x of t minus tau. So when you put t equal to 0 in this expression, you will get x of minus tau. Okay. Now this thing is clear. Now we have time reverse and shifted x of t function. Okay. So we will shift only x of t function, keeping the h of tau function constant. Now if we look at this case, it is something like this. Okay. This amplitude is 3. Amplitude is not a very important thing which is must in this, which has to be, okay, amplitude is only when it's multiplied, but the limit of times are very important. Okay, so we got expression something like this. Now here this thing will move across this ht. Okay, this will completely move across slowly, and then it will come out. So once it will come out, during this process, whatever the results are performed in this, they are nothing but the output yt. Okay, we will see one by one how the things will change. In this case only, if I see t plus 1 is lesser than 0.5, then there is no overlap. Okay, thus yt is equal to 0 from minus infinity t less than equal to minus 0.5. Okay, so t will be lesser than minus 0.5. So up to this case there will be no overlap. Since there is no overlap, yt will be equal to 0. Once the overlap will start, yt will have some value. Second case. Second case, there is a probability, there is a chance. Since we have seen the first case, so in this case definitely it is going to be inside ht. Amplitude is 2, this is 3, this is t minus 2, this is 0.5, this is t plus 1. So you are now inside the ht. So this is a common overlap region. Now what will happen? T plus 1 value can lie between 0.5 up to 2.5. Thus minus 0.5, 1.5, this value will lie. So now I have to integrate 0.5 to t plus 1 x t minus tau plus 1 dot 2 d tau. Okay. On solving this expression, we will get yt t tau minus tau square by 2 plus tau 0.5 to t plus 1. This will lie between 0.5 less than t less than 1.5. Okay, this is second expression for yt. Now case third. In case 3, what will happen? See this. Your h tau is remaining constant at the same place. There is a possibility some portion is lying inside and other portion may be lying outside. So this is t minus 2 and this one is t plus 1. Okay. So here when this will happen, t minus 2 will be lesser than 0.5. This implies that t is lesser than 2.5. T plus 1 is greater than 2.5. This implies t is greater than 1.5. So within this region, I can write my yt is equal to 0.5 to 2.5 t minus tau plus 1 dot 2 d tau. Okay, for 1.5 lesser than t less than equal to 2.5. So this is another condition. I should not write here equal to because earlier we have taken the case 1.5 lesser than t less than equal to 2.5. Okay, so this is one more case in which the common region is this. This common region is lying between 0.5 to 2.5. That's why the limit of integration are 0.5 to 2.5. Okay. Fourth case will be like this. Now this has started moving out from HT. Okay. In this case, two limits are there. T minus 2 greater than 0.5. T minus 2 is less than equal to 2.5. From this I will get t greater than 2.5. From this I will get t less than equal to 4.5. Okay. Thus, the limit of t will lie between 2.5 to 4.5. Yt will be t minus 2 to 2.5. This is a common region now. So I am integrating between this limit and this limit. T minus tau plus 1 dot 2 d tau. Okay. Solve this to get the yt. The range will be okay. Last case is something like this. This has completely moved out from HT. When this will happen, there is no overlap. Once there is no overlap, yt is again equal to 0 for t minus 2 greater than 2.5 t greater than 4.5. Okay, so 5 cases will arise. Depending on depending on each case, we have to integrate separately. We have to take the limits carefully, limits of integration carefully, and solve the integral to get the answer. Okay, so in this way, continuous time convolution is solved. Okay, this is a very general example, but in GATE exam, such problems may not come because they take lot of time. In return, what they can ask is, what is the value of yt when limit is this? Okay, at that time we have to choose the limits carefully and we have to find the value of yt. Now we will take one example for discrete time case. It will be a similar example. One, two, three, four, each having amplitude equal to 1. Okay, that means I can write my Hn equal to 1 for 0 elsewhere. Okay, similarly, Xn will be, Xn I'll draw something like this. Three and 4. Okay, so Xn can be written like 1, 2, 3, 4 centered at this. This symbol indicates that this is a origin position. Okay. If we want to find yn, which is hn convolve with xn. So this is the problem which we want to find. Now see the solution. First, the limit of n. -1 plus 0 less than equal to n less than equal to 4 plus 2. So this will be -1 less than equal to n less than equal to 6. Total number of terms will be there. Okay. Now I will just draw x of n minus k. H of k will be something like this. There is no difference. Okay. X of n minus k will be drawn like this. N plus 1, n minus 2. 1, 2, 3 and 4. Okay, we got both the things. Now we have to find yn. We'll take first case. When n plus 1 is lesser than 1, at that time there is no overlap. One mistake we have done. The limits of n, I'll just write down again. Limits of n will be minus 1 plus 1 lesser than n less than equal to 4 plus 2. So that will be 0 less than n 6. Okay. So now taking the case 1. When n plus 1 is lesser than 1, there is no overlap. Thus yn is equal to 0 for n less than 0. Okay. Now case 2. When n plus 1 is equal to 1. Okay. At that time there will be an overlap. Thus I can find y of, this implies that in the first case I can write y of 0, y of minus 1 is equal to 0. So here y of 0 will become 1 into 1 is equal to 1. On the similar lines, if I draw, it will be something like this. This is my h of k. Now if I make x of n minus k, so it will be just like overlapping. I can write overlapping x of n minus k over hk. Okay. So for each term you can write like y0, y1, y2, y3, y4, y5, y6. Okay. Now what is y1? y1 will be 2 into 1 plus 1 into 1, which is equal to 3. Similarly, y2 will be, again it is shifted more inside, shifted more to right hand side, become 3 into 1 plus 2 into 1 plus 1 into 1, which is equal to 6. y3 is equal to, again shifted, it will be 4 into 1 plus 3 into 1 plus 2 into 1 plus 1 into 1. This is equal to 10. y4 is equal to, again shifted by 1. This time what will happen? It will come 0 into 1 plus 4 into 1 plus 3 into 1 plus 2 into 1. This will become 9. y5 is equal to 0 into 1 plus 0 into 1 plus 4 into 1 plus 3 into 1. This is equal to 7. y6 is equal to 0 into 1 plus 0 into 1 plus 0 into 1 plus 4 into 1 equal to 4. Y7 will be equal to 0. Okay. Thus yn is equal to, I can write from the beginning, 1 comma 3 comma 6 comma 10 comma 9 comma 7 comma 4. Okay. The number of terms in yn is equal to 4 plus 4 minus 1 is equal to 7. Thus, the total sum in the output expression will be sum in the input plus sum in the system function minus 1. Take one more problem. Find yt, which is equal to convolution of step function with step function. Okay. Solution for this. Here, the t value will lie between 0 to infinity. So, I have to integrate yt from 0 to t 1 into 1 dt. Okay. So, which is equal to t. See, ut is this expression. Okay. Another ut is same way. So I have two ut here. So when I convolve one ut with another ut, I will get expression something like this. Equal to t, this is equal to 0, this is the overlapped region. So when I multiply this overlapped region, this will be yt equal to, limit of integration is 0 to t, 1 into 1 dt, where t lying between 0 to infinity is equal to t. This problem have once appeared in GATE exam. See one more problem. ht is equal to e to the power minus 3t, xt is equal to e to the power minus 2t. For here t lying between 0 to infinity, for here also t lying between 0 to infinity. Find yt, which is convolve of ht with xt. Okay. A range of t 0 to infinity. Okay. Now this expression is something like this. This is your ht and this will be x of t minus tau. This is t, this is equal to 0. Okay. I can write this expression h of tau. Now yt will be equal to minus, integral of 0 to t e to the power minus 3 tau dot e to the power minus 2 of t minus tau t tau. So this will be equal to 0 to t e to the power minus 3 tau dot e to the power minus 2t e to the power plus 2 tau t tau. On solving this integral, I will get e to the power minus 2t outside, e to the power minus tau by minus 1, 0 to t. So it will be e to the power minus 2t minus e to the power minus 3t yt for t ranging from infinity. Okay, this way this type of any type of convolution process can be solved. Okay, so this is something which we want to tell about the convolution. A very important topic, and we can expect at least one question from this topic in GATE exam. Okay, so we have to be thorough with the topic, we have to be thorough with how the integration process is there. Generally in GATE exam, discrete time convolution is preferable than continuous time convolution, because the discrete time convolution gives some finite number of values which are easy to calculate and which also helps in understanding the concept. Okay, examiner can find how much the concept of convolution is clear to the student on giving that problem from the discrete time system.